Hello friends, welcome to the number one educational channel Electrical Exclusive. In this class we gonna discuss the NOR gate. As this name signifies, the equivalent logic circuit of the NOR gate should consist an OR gate and a NOT gate. This is the schematic symbol of the NOR gate, which has two inputs such as X and Y. On the opposite side, this is the output terminal, which we shall label as Z. To understand the function of the NOR gate, we need to decode this NOR gate. This is the equivalent logic circuit of the NOR gate. These two terminals are the input terminals X and Y, and here we shall get the output, which is Z. In other words, to construct a NOR gate, we need two gates, an OR gate and a NOT gate. And the input terminals either receive a logical 1, which is high input, or a logical 0, which is a low input. Each logic gate has a truth table that displays the different combination of inputs along with the respective output. Now let's find out the truth table for the NOR gate. As we know, the output of the OR gate is simply the summation of the two inputs. That's why over here we shall get a signal X plus Y, and which will be inverted by this NOT gate, and it becomes X plus Y bar. So let's go for the truth table. On the left hand column we shall register the inputs X and Y. On the right hand column we shall register the output, which is Z. When both X and Y are 0, now come to the equivalent model. X is 0, Y is 0. That's why at this point the signal will be X plus Y, which is 0. And this 0 will be inverted by this NOT gate and it becomes 1. So output is 1. When X is 1 but Y is 0, come to the equivalent logic circuit. X is 1, Y is 0. So at this point the signal will be 1 plus 0, that is 1, which will be inverted by this NOT gate and becomes 0. So output is 0. If X is 0 and Y is 1, 0, 1. So at this point the signal will be 0 plus 1, that is 1, and this signal will be inverted by this NOT gate and it becomes 0. So output we got is 0. Now we shall verify the final case. If both the inputs are 1, X is 1 and Y is 1, so no doubt over here the signal will be 1 plus 1, that is 1, which has to be inverted by this NOT gate and it becomes 0. So output is 0. For the NOR gate, the output is available only when both the inputs are 0. Now let's go to the simulator to see the working model of the NOR gate. So friends, this is the NOR gate. To supply this NOR gate, I need two logic sources. Now I need a LED to see the output. The circuit is still not complete because we need to connect a current limiting resistor, whose resistance will be 150 ohm. Well, let's see. At this moment both the logic sources are at state 0 and the output is high, or the output is 1, and that's why the LED that we have connected on the output side is glowing. If I flip the first logic source to state 1 and the second to state 0, you can see the output is not available, that is 0. Now if I further change the first logic source to state 0 and the second to state 1, you can see the output is not available, that is the output is 0. And now if I flip both the logic sources to state 1, you can see the output is still not available. So for the NOR gate, the output is available only when both the inputs are low. Friends, don't forget to subscribe our YouTube channel Electrical Exclusive.